Assalamualaikum and hi everyone. In this video, we will gonna present our group project entitled Home Heating. Let me introduce my group members. So first, me, Najiha, and the second one is Sharafana. The third one is Aina Shaira, and the last one is Izno. So I'm gonna start with the introduction first. In this project, we use the Newton's law of heating, which defines the temperature change in an object whose atmosphere is hotter than it is. Newton's heating law is X prime T equal to K in the bracket Tt minus Xt. Next, the objective of the study that we need to achieve are first, to determine the first order differential equation of home heating using matrix differential equation. The second is to figure out the time taken for a furnace to increase the temperature of the house. In this project, we choose to use the model house for our mathematical modeling. To avoid overcomplicating to our model, we will ignore the heat loss through the floor of the house.
The mathematical model, which is a house, has a furnace capable of raising the house temperature at a rate of H per hour. If the house temperature is initially the same as the outdoor temperature, how long will it take for the house to reach 68 degrees after the furnace is turned on? Assume the simplified situation where the outdoor temperature T is a constant, 35 degrees. The furnace is always on and the H equal to 20 degrees per hour. So here's the mathematical equation and the parameters used in the equation.
Okay, now I will present to you our manual solution. Firstly, this is our mathematical model. After we expand the mathematical model, we get this equation, and then we use the method of undetermined coefficient, we get this equation. Then we took out the A. From A, we need to find the eigenvalue. After we do the calculation, we get two values of eigenvalue, which is R1 and R2. Next, we need to find the eigenvector. For R1, after we do the calculation, we get this value. Next, we find the eigenvector for R2. After we do the calculation, we get this value. After we get the value of eigenvalue and eigenvector, we substitute into our general solution. And then we get the constant A1 and B1. Next, from the equation, we need to find the value of A1 and B1. After we do the calculation, we get the value of B1. After that, we substitute B1 into the equation, we get the value of A1. Okay, now after we get the value of A1 and B1, we substitute the particular solution into the general solution. And then we substitute the initial condition into the equation. Then we get this equation. Lastly, we need to find the value of C1 and C2. After we do the calculation, we get the value of C1 and C2, we substitute into the equation, and now we get the general solution.
Next is the computer-aided solution. To answer our problem, we use Python software to solve the system of ODE. So first we define our ODE system and we calculate to find the general solution. So as you can see is in the picture, the general solution for the computer-aided solution and manual solution is a bit different for the value of C1 and C2. However, the x1t and x2t equation is same for both manual solution and computer-aided solution. So next is this is the coding for to plot the graph, and this is the graph that we kept.
But we had used Python to find the general equation and to plot the graph. So here is the result. So the graph displays the temperature of house and the temperature of attic in Celsius by time in hours. From the graph, it can be concluded that the temperature of house and the attic increases rapidly at the first 10 hours and remain constant after that. However, the temperature of house is always higher than the attic temperature, as attic temperature always remain below 60 degrees Celsius.
Hi, I'm Sharafana. So to conclude our presentation, we can say that the heating process of Newton's law of cooling can be described into two first ordinary differential equations, which we have solved by using the matrices method and also method of undetermined coefficients. Home heating is of course applied in real-world application. And here are some recommendations to increase the efficiency of home heating. Firstly, we can increase the home heating efficiency by installing a thermostat timer which can raise and lower the temperature automatically. This can save fuel and money. Secondly, we must also take into consideration about where we want to place the thermostat, because if we misplace the thermostat, the accuracy of the thermostat will be compromised. Hence, with that marks the end of our video. Thank you for watching and Assalamualaikum.